Hi everyone, I'm Xin. Thank you for attending my talk. My presentation today is for our paper accepted to Senior 2021. The paper title is A Survey-Based Empirical Evaluation of Bad Smells in LabVIEW System Models. Before jumping into the paper, I would like to briefly introduce some basic background for the paper. The very first concept I would like to introduce here is bad smells. The investigation of bad smells became popular after the publish of Martin Fowler's book, Refactoring, Improving the Design of Existing Code. In this book, he defined bad smells as a service indication that usually corresponds to a deeper problem in the system. Bad smells are common in our software development practice. For example, bad smell long method may be shown in the program when the new functionalities keep on adding to the existing requirements as the software evolves. When we simply use Ctrl+C and Ctrl+V to repeat a piece of code, we may have another common bad smell called duplicate code. Researchers have shown that bad smells in code cause deeper frustration to programmers and take longer time to debug. Since the investigation of bad smells became popular, numerous studies have been conducted to analyze the bad smells in the area of object-oriented programming. However, bad smells investigation is still poorly examined in other fields. Our research focuses on bad smell investigation in the area of model-based systems engineering. In this slide, I listed two commonly used systems engineering platforms. One is Simulink, and one is LabVIEW. Our paper examined bad smells in LabVIEW system models. LabVIEW is a systems design platform and design a systems development environment for visual programming language from National Instruments. There are three reasons why we chose LabVIEW as our research artifact. First, LabVIEW is a popular tool that used both in industrial development and academic teaching and research. Second, the existing literature on LabVIEW bad smells is very limited. Third, we are currently collaborating with National Instruments, which makes us easy to get access to the professional LabVIEW experts. Now, I'd like to discuss the existing literature on the bad smell summarization in LabVIEW models. Right now, there are two papers conducted in research about the summarization of bad smells in LabVIEW models. And in total, there are 20 bad smells summarized from the existing literature. And a natural question after the summarization is that, what do systems engineers perceive about these bad smells? Motivated by this, our paper proposed three research questions. The first one is, to what extent do systems engineers agree with the smells summarized in existing literature for LabVIEW system models? And the second research question is, to what extent does LabVIEW usage experience or domain influence an engineer's perception of specific smells? And the last research question is, what other smells have survey respondents observed in LabVIEW system models? Let's first look at the methodology. To answer the research questions, we designed a survey. The goal of the research is to empirically analyze whether model smells summarized in existing literature really smell bad for LabVIEW models, systems engineers. And to reach this goal, we conducted an online survey using the tool Qualtrics. And there are 5 sections in the survey. The first section is about demographics, and the section 2 to section 4 is the evaluation of bad smells in LabVIEW system models. And last section is open-ended question to ask additional model smells from the participants. To avoid bias, we only gave the description of each model smell without introducing any potential impacts. And after the initial design of our survey, we sent our survey to National Instruments experts for initial feedback to make sure the survey questions are clear. Now let's look at a sample questions from the survey. For example, like demographics. In this section, we have several questions. One question is, how long have you been working in LabVIEW? And section 2 to section 4 is empirical evaluation. For example, like one of the best smells in LabVIEW models is too many controls. For the evaluation of too many controls, our question is controls. We describe the best smell, and then we ask them to what extent do they agree that too many controls is a so-called smell for LabVIEW programs. And last section is additional best smells for LabVIEW models. In this section, we ask participants, do they have other best smells that they think they meet during the practice, but not mentioned in our survey? In order to recruit more participants, we sent our research invitation to several places. The first one is the experts in national instruments. The second one is in order to recruit more new developers' opinion, we post our survey to the online discussion forum. We also sent our survey to 15 institutional academic universities. And we also post our survey on social media such as Twitter and Reddit. Now let's look at the results. The first one is demographics. In total, 65 participants started the survey and 45 finished the survey. Among the 65 participants, you can see most of participants came from North America. One of the reasons is that the headquarters of National Instruments is in Texas. And we can also see that our participants came from different domains, such as industrial developer, academic researcher, or graduate and undergrad students. We can also see the experience of the participants. We can see that some of participants have over 15 years of LabVIEW experience, while some of the participants have less than 5 years experience. The very first research question is, to what extent do systems engineers agree with the smell summarized in existing literature for LabVIEW system models? To answer this question, we convert their answers to numbers. For example, if they strongly agree that one bad smell is a smell to them, then we convert their answer with a number of 2. So far and so forth, we transferred somewhat agree to number 1. We transferred the answer neither agree nor disagree to number 0, and somewhat disagree to number -1, and strongly disagree to -2. Then we define a metric called mean perception to evaluate the best smell perception from end users. For example, for the best smell too many controls, there were 44 participants evaluated this smell, and we added up all the perception values from these 44 participants, and the result was 23. So the perception value for too many controls is 23 divided 44, and is about 0.52. Using the same approach, we can get all the perception value, mean perception, for different best smells. As we can see from the figure, we can see that participants agree that some of the best smells summarized in the existing literature are problems to them during their development, while some of the best smells that they don't think is a problem for them, for example, like the best smells with the mean perception value below 0, we get 4 such smells, such as the loop ones or a deficient sub-VI. The second question is, to what extent do LabVIEW usage experience or domain influence on engineers' perception of specific smell, and list the result of the mean perception value based on experience. From this figure, we can see that the more experience an engineer has, the lice problem that they think these co-smells will cause to them. Another study we conducted is to analyze the perception difference between academia and industry. That we can see, in general, industry developers think the best smells summarized in existing literature cause less problem to them. The last research question is, what other smells have survey respondents observed in LabVIEW system models? In the end, we found 7 another extra bad smells from our survey. The first one is too many local or global variables. This bad smell is similar to the too many variables in the area of object-oriented programming. Another bad smell we summarize here is bad data flow. This is very unique to LabVIEW environment because LabVIEW follows the data flow paradigm of programming. Another smells include overuse of design template, or lack of comments or documentation, or lack of error handling, or inconsistent naming or style. The last co-smell we found is the LVOOP, which means the LabVIEW object-oriented programming. It's a design tool that allows users to introduce OOP concepts to LabVIEW development. Now, I would like to briefly introduce our threats to validity in the study. The first one is internal threats. You can see that we have 3 different internal threats to this paper. The first one is our analysis based on the categories instead of single smell. And we only had 45 participants, which is not very high number. The last one is we didn't ask the participants why do they agree or disagree with certain designs belonging to mod smells. To mitigate this threat, we would like to conduct a more comprehensive study in the future. Another threat is external threat. In this paper, the threat comes from whether the survey sample is representative of all LabVIEW users. To mitigate this threat, we send our research invitations to different places, such as the National Instruments experts or the beginners from the online discussion forum. The last one is construct threats. In this paper, the construct threat comes from whether the survey is clear and not ambiguous. To mitigate this threat, we sought feedback on an initial survey design from LabVIEW experts at National Instruments. This is all the presentation for me today. Thank you. If you have more questions, please feel free to contact me with this email address. Thank you.